Okay, when solving log equations, you can try any one of these steps in any order. So you could try writing it in exponential form, setting it as a y equal a to the x. You could try simplify using your log properties. Two logs added, we can condense using multiplication. Two logs being subtracted, we can condense using division. The product power property states that the number in the front can be moved to the exponent. And since log and exponentials are inverses, a log of b raised, cancel, your bases cancel, and you're just left with the exponent. Another option is to set your bases equal, thus equal bases equals equal exponents. So there's never one exact way to solve a log equations, exponential equations. You just have to see what the starting point is and try one of these options. So let's do some examples. So if we have 16, 3 to the x equals 8. Well, this is an exponential equation. Notice we have a base of 16, a base of 8. They are not equal, but let's see if we can get the same base. So 16 we can rewrite as a base of 2, as 2 to the 4th. 8 we can rewrite as 2 cubed. So 16 we can write as 2 to the 4th. We're still multiplying by the 3x. 8 we can write as 2 cubed. Well, 2 raised equals 2 raised. That must mean that our exponents are equal. So equal bases means equal exponents. Equal base means equal exponents. So 4 times 3x is 12x equals 3. Divide by 12. So x equals 3/12, which we can reduce to the fraction 1/4. Again, we can check our answer by plugging it in. You can also graph and see if the intersection points of the left side and the right side equals 1/4. So let's try another one. What if we have a 27, 3 to the x equals 81? So notice the bases are not the same, but 27 and 81 do have a common factor base of 3. Well, 27 we can rewrite as 3 cubed. 81 we can rewrite as 3 to the 4th. So 27, 3 to the x is really a 3 cubed times 3x. 81 is 3 to the 4th. Same base means equal exponents. So 3 times 3x is 9x equals 4. We can divide by 9. Thus x equals 4/9. Again, you can check by plugging it in, or you can graph and see when the left side intersects the right side. Let's try another one. What if we have 5 raised to the 2x equals 130? Well, here we have 5 and we have 130. Is there any way for us to rewrite 130 using a base of 5? Well, 5 raised to anything, I don't know of anything that will be raised to exactly 130, which means it's probably a decimal. So why don't we try rewriting in log form? Well, let's think about writing this in log form. If we rewrite in log form, big 5 becomes little 5. Of the right-hand side, 130 is going to equal the exponent. So log base 5 of 130 equals 2x. So we could write it as the exact answer, divide everything by 2. We might have one answer as log base 5 of 130 divided by 2. Okay, you could see it written as this way. Another way to write this is by putting the 1/2 out in front. Okay, that would be equivalent expression. You could also use change of base formula. Okay, change of base will give us, remember, base on bottom, so log of 130 divided by log of 5. So that is the exact answer. If you were to put it into the calculator, okay, you can put it directly into the calculator, 1/2 log 130 divided by log 5, or again into the calculator right here at log base 5 130 over 2 if you have a fancy new age graphing calculator. But if you put it into the calculator, you should get an estimated value of 1.5122. So again, all of these are equivalent expressions. SAT, PSAT, love these types of questions. Which one is equivalent to? You might see option A, B, or C. But again, if you're wanting a number answer, it's going to be the not so pretty decimal, about 1.5122. Let's try another one. What if we have log base 4x minus 3 equals 2? Well, if I have it in log form, I can't really do much with log form unless I can exactly estimate a decimal, which I can't here because x is inside the log. So let's change it to exponential. Well, what's my base? If I don't have a number as the base, that means the base is 10. So you have 10 squared equals 4x minus 3. Well, what is 10 squared? 10 squared is 100. And now we just have a linear equation. Solve for x, add 3. Divide by 4. And we end up with 103 over 4. Again, if you were to put that in the calculator, you should get the answer of about 25.75. So again, another way to check your answer, you can graph left side, graph right side, and find the intersection point. So what if we have log of x minus 3 plus log of x equaling 1? The first step is I have 2 logs. Well, if I have 2 logs, it's going to be easiest to simplify into 1 log. So if we have addition, we have the product property, which states that I can rewrite it as 1 log by multiplying. So multiplying x minus 3 times x. Well, I can simplify this. X times x is x squared. Negative 3 times x is negative 3x. Well, now I'm stuck. I got my x's attached to my log. How am I going to undo the log? Well, the only way to undo the log is, let's see if I can change it into exponential. So when you get stuck with log form, if you can't isolate the x, change it to exponential. So, what's my base? I don't have a number, which means it's base 10. So we have 10 raised to the first power equals x squared minus 3x. Well, since this is a quadratic, we need to set it equal to 0. So I need to move the 10x to the other side. So since it's positive, we're going to subtract. So write as exponential. And so now, because we have a quadratic, we need 2 answers, parenthesis, parenthesis. 2 numbers that multiply to negative 10, but add to negative 3. So options for 10, we got 1 and 10 and 5 and 2. To get a negative 3, we need a negative 5 and a positive 2. So 0 property states that we can set each of these equal to 0. Add 5 to both sides, subtract 2 from both sides. X equals positive 5 or x equals negative 2. This is when it's very, very important to check. Okay, very important to check your answers. So if I plug in 5, well, 5 minus 3, I'm taking log of 2, no issues there. Plus log of 2, those are both positives. I can take log of any positive. that one will work. And if you double check it and graph it, or utilize your graphing calculator, left side will equal the right side. Now let's look at -2. If we try to plug in -2, well, -2 minus 3, again, we're going to get -2 minus 3, which is going to be log of -5. Well, uh-oh, this does not exist. I cannot take log of a negative number. What this is basically asking is saying is that, okay, 10 raised to something is going to get me a -5. Well, even if 10 is negative, I just get a fraction. Remember, the domain of log does not go negative, again, unless we have transformations. So I cannot accept this answer. This is what we call an extraneous solution. It is an extra solution. That does not make sense. Extraneous solution. So we have to reject it. So you have to reject any number, not that it's negative, but zoop, when you plug it in, is it still negative when you take the log? And in both of these cases, even if it doesn't work for one, doesn't work, so x equal 5 is our only answer. Let's look at another one. What if we have log base 3 of x plus 12 equals log base 3 of 5x? Well, what do we notice? Log base 3 equals log base 3. Well, since we have the same logs and they're all in parentheses, these are going to cancel. And we can just say that x plus 12 equals 5x. And we can solve for x. Subtract the x from both sides. 12 equals 4x. Divide by 4. X equals 3. And again, plug it in. Make sure that we're not taking log of negative. 3 plus 12 is 15. We're good on there. 5 times 3 is 15. We are good on there. And log 15, that would check. Again, you can also graph. So let's try another one. What if we have log base 3 of x plus 1 equals 2? Well, I'm in log form. I'm stuck. I don't know what to do. Well, let's try to change it to exponential. So exponential means little 3 becomes big base 3. Squared equals x plus 1. 3 squared is 9. Subtract 1 from both sides. X equals 8. And again, we can plug in. 8 plus 1 is 9. Log base 3 of 9, well, 9 is 3 squared. Log of 3 cancels. 3 equals 2. It checks. Let's take it up a notch. So 4 log base 4 to x plus 8 equals 4 squared. Well, what do we notice here? Well, here I have 4 raised to log 4. Well, these are inverses, so they're going to cancel. So we're left with x plus 8 equals 4 squared. Well, 4 squared is 16. Subtract 8 from both sides, and x equals 8. And again, you can plug it in. 8 plus 8 is 16. 16 we can write as 4 squared. Log base 4 cancels 2. 4 squared equals 4 squared.